Welcome to the Explainer. Today, we are going to completely demystify the mechanics behind how our entire number system actually works. Whether you're tracking billions of dollars or, calculating distances in deep space, massive numbers govern our universe. But how exactly do we make sense of them? Well, it all comes down to the absolutely brilliant underlying mechanics of our math system. Let's get into it.
All right, let's just dive right in. Take a look at this massive, kind of intimidating string of digits on your screen. When numbers get this incredibly large, they almost stop looking like quantities, right? They start looking more like passwords or a secret code.
Be honest, can you read that number in your head right now? Or does it just look like a giant random jumble of math? If you're feeling a little overwhelmed, you are definitely not alone. Without a proper structure, our human brains simply cannot process a sequence of symbols this long.
But don't worry, because here is exactly how we're going to learn to read that enormous number by the end of this explainer. First, the 10 magic digits. Second, the power of position. Third, visualizing with an abacus. Fourth, grouping numbers into periods. And finally, mastering huge numbers.
Okay, kicking things off with Section 1, the 10 magic digits.
So what's really cool here is that the system we use every single day actually has a specific name. It's called the Hindu-Arabic number system. We interact with this system literally constantly, on our phones, looking at price tags, checking the clock, but we rarely stop to appreciate the specific set of tools it gives us.
Think about it like this. Just like 26 letters make up the whole alphabet to build any word in the English language, these 10 magic digits from 0 all the way up to 9 are used to build absolutely every single number in existence. From the tiniest fractions to the grandest astronomical figures, the whole shebang just boils down to these 10 symbols.
Moving right along to Section 2, the power of position.
Let's look at the number 54. It's made up of two distinct digits, right? A 5 and a 4. But why does putting a 5 next to a 4 mean 54? Why doesn't it mean 9, like 5 plus 4? Well, it all completely depends on where those digits are sitting.
The absolutely crucial thing to grasp here is the difference between place value, which is just the position, like the tens place or the ones place, and the represented value, which is the actual heavy lifting amount. In the number 44, the place value of the 5 is the tens place, but because there are 5 tens sitting in that spot, its represented value is 50. The 4 is in the ones place, so its represented value is simply 4. 50 plus 4, and boom, that gives us our number.
Which brings us to Section 3, visualizing with an abacus.
To really cement this abstract idea, an abacus is perfect because it brilliantly illustrates how we physically build numbers. If we want to build the number 34, we literally draw 4 little counters on the ones rod and 3 counters on the tens rod. You can physically see 3 tens and 4 ones. It completely demystifies the structure of math.
But check out this fascinating rule from our sources. The maximum number of counters that can be placed on a single rod of an abacus is 9. Why? Because the very second you hit 10 counters on the ones rod, they combine and shift over to become exactly 1 counter on the tens rod. So, the maximum value any single digit can represent in its given place is always 9.
All right, Section 4, grouping numbers into periods.
Now that we've got the building blocks and positions down, it's time to scale up. To read really large numbers, we separate them into groups of 3, always moving from right to left. Each of these 3-digit groups is called a period, and each period has a specific family name. Starting from the right, we have units, then thousands, then millions, and finally billions.
And here is a fantastic little mnemonic from our sources to memorize that exact order from right to left. Just say uni, thou, milli, billy. Unit, thousand, million, billion. If you can just remember uni, thou, milli, billy, you can read almost any huge number you encounter in daily life. Now, when we write numbers out, we often see them in this chaotic general form with all the digits just mashed together. But to write these out in standard form, our sources highlight a very specific formatting rule. We don't actually use commas. The strictly correct way to write this in standard form is to leave a small, distinct gap between each period of 3 numbers. This visual separation just makes it infinitely easier for the human eye to process.
Which leads us to our final step, Section 5, mastering huge numbers.
So here is that monster number from the very beginning, but now it is properly grouped into periods of 3,
starting from the right with those small, correct gaps spacing them out. Suddenly, it looks way less like a barcode and much more like distinct, readable pieces of information.
And if we drop those group numbers straight into our uni, thou, milli, billy table, the mystery completely vanishes. All we have to do is read the numbers in each box from left to right and just say the name of the period right after it.
Let's read it together. 48,037,890,445. And notice we don't say units at the very end. We just read the final number. You did it! What was a jumbled mess at the start of this explainer is now completely legible to you, all because you understand the underlying system.
Before we wrap up, I'm going to leave you with the final challenge straight from the Lunka Past Papers math exercises. Using the power of position we just learned, what is the absolutely greatest number you can construct with the digits 8, 3, 7, and 2, using each only once? Think about which digit needs the highest place value to make the biggest impact. Try to picture it on an abacus. Keep analyzing, keep calculating, and I'll see you in the next explainer.